Okay, so welcome to today's digital network meeting. It's not the 27th of September, thankfully. We are in January. Apologies, I obviously forgot to put the date there. But we are in the 31st of January. Believe it or not, we're almost at half term, which is great. Quick overview of today's agenda. An update essentially on our professional learning offer and our professional learning opportunities that are available. We'll have a quick presentation from Simon and Anta Park, who's going to present on progression in computational thinking and computer science. We'll also then look at a workshop then with Luke from Technocamps, who we're delighted to have here today, who's going to be sharing some key thoughts and ideas around the use of Scratch in the classroom. So I'm really looking forward and excited to hearing from Luke and the Technocamps team this afternoon. So, just an update then on professional learning. Professional learning offer have been running this year. Lots of fantastic opportunities available for digital and across the board. And a reminder to everybody that you can access the professional learning offer via the Supporting Our School site. As you may be aware, all sessions now must be booked through the dedicated booking portal, which is Ticket Source, and session booking will now close 1 week before the start date. It did used to be 2, it is now 1 week before the start date, so please, if you are interested in attending any courses, please do try and book in advance if you can. And if you have made a booking and you're unable to attend, please do let the business support team know, and we can release that space for somebody else to attend. If you want to have a look at the full offer, you can either click on the image on the screen there or on the blue link, and that will take you through to the full offer in terms of everything that we have available. With regards then to the network meetings, we're lucky this is the third one we've had this year, looking to run one every half term. So far, we've obviously engaged with Interfilm and Data Cymru with a theme around sort of expressive arts and the maths and numeracy side of the curriculum. Today, we're going to be, again, working with Luke and the Technocamps team to think about computational thinking and computer science. The final 3 sessions for this year then will focus on humanities, and we're lucky to have Britannica coming along to run some workshops for us on the 21st of March. On the 21st of May, we'll be working with Microsoft to look at some learning accelerators, things like Reading Coach, Speech Coach, Search Coach, some fantastic tools that are now available for learners in the classroom, looking at accessibility and how that can make sure that all learners are able to engage in learning. And the final session, the 2nd of July, is going to be a in-person session, hopefully being held at the University of South Wales in Newport, just like we did last year. Not so much conference size, but more of a networking opportunity where schools that are engaging with some of our projects will be sharing their findings throughout that day. So please get those dates in the diary if you can. It'd be great to see as many of you along to both the virtual and the physical sessions as we move throughout the academic year. Just an update then on the professional learning offer that we have available to all schools. Again, very, very popular this year. The digital skills for teaching assistants program over 2 days. We have one final cohort that is available to book, and that's the 3rd cohort, which will be running in April up at Georgetown Primary School. So a 2-day program developing skills and confidence for the teaching assistants in your school. So if you'd like them to engage in this program, you can QR code on the screen there. You can sign up via the QR code, or again via the brochure on the Supporting Our Schools website. All the slides will be shared after the session as well, so if you do want to go back afterwards and scan that QR code and book on, you can. Another really popular opportunity is our computing for primary teachers. We've partnered with Luke and the Technocamps team here to train up a number of teachers across the region in delivering this program. It's a 3-day program developing that deeper understanding of computational thinking and computer science and how we can apply that within Curriculum for Wales. The first cohort sold out very, very quickly, and I believe there are about 6 or 7 spaces left now on the second cohort, which will be running in May, June, and towards the end of June this year. So again, if you're interested in developing that deeper understanding, or you feel like there's members of staff in your school team that might want to engage with that, please do get them signed up. The team at Maindy are fantastic, and the feedback we had from the first session that we've run in the first cohort has been really, really positive. With Technocamps in mind, we are also running a microbit in Curriculum for Wales session on the 10th of April at the University of South Wales Newport campus. This was sold out. We did max out on the 30 that were available, but I've spoken to Reese and the team, and I've managed to twist his arm, and there are now another 5 spaces available. So if you are interested in developing your understanding of the microbit and how that can be used in the classroom, essentially what it is, what resources there are available, how that can be used as part of the curriculum in your school, please do sign up to those sessions. Like I said, first come, first served. We will have a waiting list. And if you have already signed up and you're not able to attend, please do let me know so we can release that space for somebody else. I'm sure Luke may share that there are other opportunities to engage in sessions like this in his presentation, so I won't steal his thunder at this point. Another session, or another 4 sessions that we're looking at, is the use of artificial intelligence in schools. This is a hot topic, as we know, and believe it or not now, I think the big rise of ChatGPT was about 12 months ago. It was around this time last year where it kind of really exploded into the ether. As schools now, we really need to be mindful of the use of artificial intelligence in our schools. So we've designed and are going to deliver 4 sessions looking at this over the next term. So to break it down into the 4 sessions, the first session is essentially just an introduction into what artificial intelligence is, what are the benefits and what are the risks. So this is really aimed at your senior leaders and your digital leads in school to kind of demystify artificial intelligence. We do not have robots that are going to come and take over our schools and the world. Okay, it's all about getting an understanding around what artificial intelligence can do for us in our systems. The second session then, which will be at the start of March, we'll look at developing guidance for our schools to ensure the ethical and appropriate use of artificial intelligence. We've called it guidance rather than policy because I believe, and Luke may agree with me here, that if we write a policy on artificial intelligence today, tomorrow it's more likely than not to be out of date. So it's going to be around how we can make sure that our policies in school, our safeguarding policies, our online safety policies, and the guidance that we develop around AI is robust enough to ensure that it's used responsibly by teachers and also by pupils when we get to that point. The third session then in the middle of March, we'll look at how teachers can use AI effectively to get the best results that they can. So we're going to look at prompt craft and how different styles of prompts can get you different responses. And then the fourth session at the beginning of April, we'll look at AI in the curriculum. How are we teaching about AI and what it can and can't do? What tools are currently available? So I know the Adobe tools are currently within the Hub Suite, but also some wider things that are coming down the line, such as Reading Coach from Microsoft, Speaker Coach, and so on and so forth, all use artificial intelligence to be able to deliver their messages. So 4 sessions there. You do unfortunately need to sign up for each one individually, so the QR codes are there. But again, you'll be able to do that following today's session via the recording or via the presentation notes, which will be in the team space. Finally, then, just a nod to the secondary networks. These were really really popular at the beginning of this year. We'll be running them again now in April. 3 separate sessions running throughout the day at Askell, Goving, Cwmrymni and Blackwood, a session on computer science, a session on digital technology, and then also a session on the DCF across the curriculum of secondary schools and what that essentially looks like. So if you're interested in attending any of those sessions as a secondary lead in your school, please, again, sign up to those via the QR code, and I will also send these out via email. That's essentially an update from us in terms of our professional learning. A quick view and look towards the updates that are coming from the Hub team. Just a quick note, as we should all be aware that next week is Safer Internet Day on Tuesday, and there are a number of resources available via the Hub platform that you can engage with to support this in your school. Obviously, the first link there will take you through to the resources that have been developed by the Hub team and wider sort of stakeholders around Safer Internet Day. There's also then 3 other webinars that will be really interesting to attend. The first one looks at understanding, preventing and responding to online sexual harassment with ChildNet, and that will be running on Thursday. Second session then running with Estin, looking at developing the right school culture and approach to keeping learners safe online on the 7th of February, which is really, really important. I listened to a talk from Estin last year around this topic, and they're really, really keen to ensure that our online safety policies were up to date and being used and are robust enough in our schools. And then finally then on a Thursday as well in the afternoon, a look at the 360 Safe Cymru tool from 4 till 4:30 p.m. And that leads me nicely just to remind schools that you do have these self-evaluation toolkits available, both the 360 Safe Cymru, looking at our online safety policy, practice and provision, and also then the robust 360 Digi Cymru tool, which looks at evaluating your whole school approach to digital, making a thought around what that looks like in terms of your leadership. What does the curriculum look like, and what does that say? What professional learning are you providing for your school? And also then the ed tech and the infrastructure piece as well. Just as a little bit of an update, and I think just to say on the 360 Safe tool, I had a little bit of a number crunch this morning, and these next couple of graphs kind of just indicate the last time schools were logging into the 360 Safe tool or updating it. So the blue bar demonstrates that how many schools were logged in at each year. So in some cases, we have some schools across Monmouthshire that haven't logged into 360 Safe since 2016, 17, 18, 19, or updating it then. That's Blaenau Gwent, sorry. In Caerphilly, similarly, we've got lots of schools in this 2017 to 2021 region, but we've not logged in or updated anything within the 360 Safe tool. For Monmouthshire, again, from 2016 to 2021, a number of schools there who haven't logged into 360 Safe and sort of updated the tool to ensure that everything is up to date and we are aware of all the changes in the policy that are available. Similarly with Newport, quite a good uptake here in 2022 to 2023, but still some schools that haven't yet logged in or updated anything on the 360 Safe tool from 2021 and before. And also then finally, schools in Torvine. So bit of a good uptake here from 2021 onwards, but still a number of schools that haven't logged in since sort of 2020 or updated the tool in terms of 360 Safe. So I think this is really, really important that if you are in a digital lead in one of these local authorities and you haven't logged in to see any of the updates on 360 Safe, I'd highly recommend you do so. Which does lead me on quite nicely to this last sort of piece of information from Estin around the supplementary guidance of the inspection of ICT in schools. Now, this was updated back in May 2023 and is a really useful document to kind of give you as a lead an understanding of what Estin will be looking for when they're inspecting sort of digital in your schools. Now, you can access that document by clicking on the image there, or clicking on the link at the top of the screen. That will take you through to the document. But I just wanted to highlight some of the questions at the bottom of the document. In one of the appendix, there is a section on questions that Estin will ask digital leads in schools. One of the questions, or one of the sections, is specifically around online safety policy and procedure. So they want to know how secure are your policies and your procedures. Do you use the 360 Safe tool to review and improve your online safety policy? And if you're not using that, what are you using and is it robust enough? So they are specifically looking to see whether schools are using 360 Safe to ensure that learners are safeguarded online. So I highly recommend you taking a look at that document, but also having a browse through the 360 Safe tool to make sure that everything in your school is robust as it can be. In regards to some of the updates from Adobe, and they wanted me to share these with you, there are a number of Adobe Express live lessons running over the next week. So lots to do with Safer Internet Day next week. You can click on the blue link there, sign your class up to one of the sort of live sessions, which will be run by either Dom or Meredith. And I believe they are available in English and in Welsh. And also to supplement that then, they are running some sessions next week on the Adobe Creative Educator Level 1. So again, you can sign up to those by clicking on the link on the screen there, and that will take you through to that training and that opportunity for you. So that's just a quick update on the professional learning that's available from us. Luke, do you want to go now, or do you want me to come back to you after I've done Simon's little video?
Probably I'd say play Simon's video, then I'll just take the rest of the time with me.
Fabulous, no problem at all. So if there's any questions around professional learning or you want any extra support, as always, you can get in contact with me and we will try and facilitate either support from myself or from one of our partner schools across the region. Okay, so that leads us on nicely to a short presentation from Simon on the progression of computational thinking and computer science at Nanta Park Primary. Unfortunately, Simon was unable to attend today, but he has recorded a video for us, which I'm now going to play. And if there are any questions you'd like to ask Simon, please pop them in the chat and I can send them on to him following the session today.
Pranamdar, everybody. My name is Mr. Tilley. I'm the digital lead, reception teacher and family engagement officer at Nanta Park Primary School in Llangennith in Caerphilly. I also have the privilege of being part of the Lead Network Schools team for digital. I'm working alongside Sean. He's asked me today to talk to you a little bit about computational thinking and what that looks like in a school setting at our school at Nanta Park Primary School. If you want to follow any of my shenanigans or you want to ask me any further questions after today's video, you're more than welcome to drop me a message on Twitter, which is the easiest place to get me on. And my handle is @SuperMrTilly. Okay, so I'm going to talk to you a little bit today about the importance of technology in our school, how it can have a massive impact on our learners and our staff, and what ways you can incorporate authentic opportunities for your learners and your staff to develop their computational thinking and data skills across all age groups. I'll also share some free resources that you can use today with your class to support the teaching and learning of computational thinking and data. And for me, it's one of those things, I think, when I ever speak to staff, whether it's at my school or other school or friends of mine who are teachers, when it comes to the DCF, I think computational thinking and data is not only the one that staff feel less confident with, because of Martik's law and the way technology is forever evolving. It's also the one that I think our peers and inspectories, such as Estin, it's always the one they kind of own in on, is databases, data, computational thinking, coding. What does that look like? And to be honest, you're doing it every single day. So I hope I can show you some examples today that will make you go back to schools and then think, I can implement this much easier in school. Okay, it's without no doubt that technology is a massive part of not only our lives as practitioners, but to our learners as well. We live in a 21st century where our lives are dictated by technology. I cannot leave the house without my phone because I will be lost. Not only does it give me the maps to help me to drive to where I need to go, it's my contact with anyone I need. I can read emails at any point, anywhere in the world. I can also pay for things off my phone. I was recently out and my phone died, and you will not believe how lost I felt without my phone. We've become reliant on technology so much. And I think having a balance for technology is so important. And showing our learners that too is really important. Our children are coming to us, even in nursery reception, in the PS1 stage, showing that technology is a massive part of their lives already. And I think it's important that we use technology in a way that's not just as a toy or as a reward, but in meaningful ways that can upskill our pupils and our staff to become digitally resilient and digital competent. It's also so important because the next generation of workforce focuses primarily on digital. I don't know if you've spoken to your learners, but whenever I speak to my digital leads, my pupil leadership, or my older children in the school, even my younger children, when I ask them what they want to be when they grow up, it's always linked to technology, whether that's a Twitch streamer, YouTube streamer, even the fact that our children want to go into esports, which is a massive thing across the world currently, is a huge part of our children's possibilities for moving forward. And you can see from the data here, the biggest skills for our young learners going into jobs is technology skills, higher than creativity. Even the top 5 in-demand roles currently is IT and data. And this hasn't changed over the last few years either. But like I said earlier, I believe it's all about balance. I teach reception class, and at the end of the day, I have a choice. I can either put something on the interactive whiteboard to get them on the carpet, or I can read them a story. And 9 times out of 10, they are much more engaged in learning, more critical thinkers, and enjoy the experience more when I read a book or when I speak to them face to face rather than if I put a screen in front of them. I also find the behavior is also better when I'm engaging with them. They still need that, no matter if that's nursery to year 13. Okay, so I'm going to focus now a little bit on computational thinking and coding, because like I said previously, it's the one that whenever we speak about digital and how we're teaching digital school, when you say coding and computational thinking, this sometimes is what people think of. They think of the raw code. They think, oh, I'm lost. I don't know what I'm doing. What equipment have we got? Are people still using that? And some people think that you have to jump on the next bandwagon of the best new resource, the best new thing. And to be honest, the majority of computational thinking and coding can be taught without a device. And I think it's so important to use Unplugged as definitely a base across all your groups. So it's easy when you go into schools to identify the coding equipment straight away. Some people rely on the B-bots or the Blue-bots or the Spheros, the Lego WeDo kits. You've got the iWonders, the Primos, the Ozobots, the robots, even the ROMbot, the old school ROMbot when I was in school. It's not difficult to find resources for coding. The media and consumerism has picked up on the fact that computing, coding is a massive thing. And there are lots of workshops and lots of resources you can buy. But there's a lot of things you can do that is more authentic that you can do without even having to touch a resource. Because at the end of the day, coding is problem solving. It's finding a problem, thinking about that problem, and finding a solution. One of my favorite activities to do with any year group is the sandwich activity. You get your children into class, you explain that today we're making a sandwich, you have all the ingredients and all the resources out. Then as a whole class, you ask the children to tell you how to make the sandwich. And you directly take on what exactly their instruction is and you do it literal. This is a brilliant introduction to coding for any year group. For example, I've had my class, you need to spread the butter. And then there's me spreading the butter across the table. Your children will be engaged, they'll love it. But what they'll learn from it is the fact that they have to think about their instructions. They have to think about their language. They have to think about the code. And it's introducing this language early on, even in PS1, that can help build these connections later on. Because again, that is what coding is. It's being critical thinking and problem solving, which is a huge part of our curriculum. Authentic opportunities, anytime you use instructions, can be used. I recently did the story, we're going on a bear hunt, where a family go out to different parts and they go on a bear hunt. Each place they travel, there's a different action. Recently, I did this in PE and I mixed up all the actions. As a activity linked to my PE, the children had to decode and debug the problem, solve it and fix it. That's computational thinking in a PE lesson. Anytime there's instructions, whether this is through cooking, reading, writing, sport, you can implement coding. What you need to do is highlight the fact that this is coding, you've got an algorithm, and using those keywords can help support the teaching and learning of coding. So when we look at actually what the government curriculum document says about coding and computational thinking, the strand focuses on problem solving and modeling. And you can see I've highlighted here the parts that actually focus on particular digital references or where digital is needed. For the majority of PS1 and PS2, you can see that you can get the majority of your coding done without touching any piece of technology. You can teach these in day-to-day strands, linking them obviously to the DCF and making your learners aware that this is the same as when you can use instructions for computers and coding. And computers are basically your brain, so you can link that into your children as well. We at Nanta Park try our best to give our children the most authentic, engaging, motivating opportunities we can. And bringing coding into a variety of them is super easy. And since I've been introducing this kind of thematic approach to coding, our children have not just engaged with it, but made massive progress. Even things like the block playroom or the Lego that you've got that may necessarily not be linked to coding. You could give your children provocations and challenges to try to build a thing in a certain amount of way. They could decompose it to make it the smallest way they can. Can you build a helicopter car with the least amount of equipment? You're getting your children to problem solve. You could get them to work in teams. PE is another brilliant one where you can introduce it. There's loads of actions, loads of movements. You can get the children to do these in loops and repeating patterns. One of the ones for me I love as well is using those B-bots and Blue-bots, or even your physical stuff, to retell stories, to recount stories, to tell instructions through your language, through your Welsh. You could even get story maps and get the children to draw the different parts of a story or the different things they've learned on their learning journey, and then program the B-bot to go to the different parts of their learning journey. You could even use emoji maps, like story maps, but getting the children to think about what they want to use in regards to engaging with digital skills. Cooking is an amazing way of incorporating computational thinking, problem solving into your lessons. There is so much learning opportunities that come from cooking. It's engaging, It promotes healthy eating. It promotes mathematical language. It promotes problem solving, critical thinking, following instructions. Cooking is an amazing way to utilize computational thinking in your schools, and the children love it. Another lovely one you can do in expressive arts that worked well in my class is getting the children to play songs as a challenge in the classroom and get the song to be mixed up, and then the children have to problem solve. There is nothing easier than when a child hears the happy birthday song, but it's wrong. This is a song that in their brain, they know that pattern so well. So when it is wrong, they can identify that problem through sound. A brilliant way of incorporating it. Provocations in the areas can also help as well. I find sometimes giving the children a problem and just leaving them to solve the problem on their own is much more powerful than you step-by-step guiding them through Model A teaching. Now, you can always use other equipment as well. There are brilliant sets linked with Lego, which we've had massive success with as well. And there are lots of revenues that you can use. There are so many resources available out there for coding, some free, some expensive. Use what benefits and support your schools. If you've got a Lego League in your school, jump into that. If you're using Minecraft in school, jump into that. It's all about diversifying your curriculum and making sure that the digital skills you're teaching your learners are purposeful to your learners and your staff. Don't bother training your staff up on blue bots if you don't have any blue bots. Think smart and think about how you can really enrich learning experiences using computational thinking and data in your schools that is meaningful to your staff and to your learners. And it doesn't matter what age group you're teaching coding. If you feel you need to go back to the basics, this is a simple thing to do. There are loads of resources on the Hub platform too, linked to Unplugged, and Technolabs have got some amazing stuff too. Check out all the stuff they've got on there. We've done some lovely things with body movement, body percussion. We've even done things like when we were designing and creating our craft for a Christmas fair, we used computational thinking to break down and problem solve how we were going to achieve our goal. Even your day-to-day tasks can be linked to computational thinking. We all have those daily timetables or those structured timetables for our class or nursery rhymes, anything with repetition, even songs. You could link flowcharts into music and get your children exploring. If I'm honest, being a DCF lead, I think nothing interlinks into the AOLE curriculum easier than computational thinking. There are a huge bunch of resources on the Hub platform, which I can imagine Sean and the team are going to speak about also today. But two off the top of the head, you've got the J2E code, which is amazing because it has all your lesson plans already there for you from year 1 all the way up to year 6. All the resources are there for all the new equipment, plus all the awesome stuff from Microbit, which I know Technolabs did a workshop with us on, which I absolutely loved, and my digital leaders and my pupil leadership are absolutely loving. And you can also use, obviously, the JIT platform as well, which is a staple in my class in PS1. I'll finish now on 2 free apps that you can download and try today with the class that we've had lots of success with, so you can have a little play around and see what you think. The first one, when I go to schools, I see a lot of blue bots and bee bots. Now, blue bots can be very expensive, plus you've got to buy all the mats, plus it's not that engaging. It's more of a gimmick than actual engaging in teaching and learning. So I would rather suggest my staff to download the Blue Bot app, which is completely free. It gives you not only access to all the maps, it also allows you to see the code on the screen, which I think is the biggest flaw with the Blue Bot, is that you cannot see that code. Also, you can import from your camera roll. How powerful is it to get your children to design a map or talk about something they've been learning or something they've built in the block play, get them to import it and then to code. You don't even need the Blue Bot then. You've got the Blue Bot built in to the app. Finally, Codeable. This is a really fun one my children love as well, and it grows with the learners. It's a free app that you can sign up to, and you can manage it as a class teacher or you can manage it as a parent. My parents love this one. And you have these furry little balls. And what you do, you have to get the ball to the end goal, but you can design your own levels, and it introduces the different levels of code. So at the beginning, it'll introduce very basic structure. Then it will look at repeating patterns. Then it will look at loops. Then it will look at decomposition. It covers so much. It's designed by practitioners for practitioners. So again, this can work on an app, plus you can use it on any URL. So you can jump on to your Chromebook and use this as well. So they are 2 apps that you can jump in today and have a look. I hope you've enjoyed this short introduction to computational thinking. Please, if you want to know any more information about the things I've shared today, you can either contact Sean or you can contact me. Like I said, the easiest place to get me is you can email me through Hub, and my username Sean will share with you in the chat. Plus my Twitter handle, which you can follow me on as well, and you can message me direct on there, is @SuperMrTilly. Diolch yn fawr. I hope you found this useful and enjoy the rest of the network meeting.
So there we go. Short presentation there from Simon, sort of looking at how they've approached computational thinking and coding at Nanta Park. As he kind of says, if there's any questions you do have for him, please do get in contact with him. And I'm going to pass you over now to Luke from Technocamps, not Techno Labs. So I think Simon was referring to Technocamps as part of his presentation on Techno Labs, unless there is a Techno Labs, and I don't know about them. But yeah, Luke, all yours. Thank you very much.
Okay, I'll just work out how I share the right screen here to make sure I don't do that wrong. I'm glad they went first for two reasons, because we had a robotics workshop going on just outside my office with robots driving into my door and children very excited. So I thought we better delay before I started speaking. You can hear all that in the background. But the second reason was that was a very good introduction to what I'm about to give a workshop on as well. So the right screen is that one. So you should be able to see my slides, and hopefully if I swipe across, you'll also see my web browser. Perfect. So, so Sean asked us to do a talk about, or an interactive session, I guess, on using Scratch across your school. And we've done a lot of this stuff in the past. And when I was thinking about what is the most useful thing that I try to get across to teachers when we're delivering these sessions in our CPD sessions and so on across Wales, it's one thing I noticed that a lot of primary school teachers, and I don't know if that's still the case, but it has been in the past, if you ask them, do they do programming? They go, yes, we do Scratch. And it's the only thing that they think about. Now, what we want to do is to push that we're trying to teach programming concepts, and Scratch is a great tool to do that, but it's not the only thing that's available. But today, we're going to be looking at programming concepts and how you can use that and use Scratch to deliver those kind of concepts and develop those skills and the understanding of those. So I basically just summarized my first slide there, forgetting that was coming up next. But yeah, programming is more than just Scratch, or if you are aware of other languages, Python, JavaScript. Obviously, the skills and the concepts you need to program, as was mentioned in the video just before, these are skills you can teach without any sort of technology. But as you get older, you want to then move them on to this sort of technology, the programming side of things, so that they are more used to these, because ultimately, if they're going to go into the workplace and jobs later on, they do need to know how to program on a computer as well as off it. So it's a nice progression from the kind of unplugged sessions you would do maybe foundation phase, or using simpler technology as was shown in some of those apps there. And Scratch Junior is another app that's quite useful on iPads if you're working with foundation phase. And then from there, what do they move on to? And Scratch is a really nice tool to use for upper secondary, and I would even argue key stage, or what used to be called key stage 3, year 7, 8 and 9 in secondary schools as well. So I'm going to kind of talk about some of the programming concepts, and these are the kind of terms you might find in the DCF and the computation element of the curriculum, and maybe you aren't that aware of how those terms, what the terms actually mean, how you can translate that into actual activities within something like Scratch. So that's what the majority of this will be. I'll show you some cross-curricular examples of how you can apply Scratch in various areas of the curriculum. And also I've got something a little bit extra for any secondary school teachers, which is a new tool that we're working on with a university in Dublin, which is a transition tool from Scratch into Python, which is a nice kind of stepping stone that hasn't really existed in the past. So hopefully that'll be of use to some year 6 teachers, but also any secondary teachers in the network here as well. So yeah, we want to focus on developing the concept and the skills, and we use Scratch most of the time because that's the most popular one and the one with the most resources available to teachers already. So these are some of the concepts that if you were going to ask a computer scientist, what are the programming concepts that need to be taught, that people need to know? And these are the kinds of terms you will see within the computational thinking aspect of DCF, as well as the computation element of the curriculum in the Science and Technology AOLE. So I'm kind of going to show you how we can address each of these within Scratch. So I will be kind of showing you how to put together code in Scratch during this. So please feel free to follow along. It'll be more useful to you if you do that. And I'll hopefully allow enough time for you to put together the things as I'm doing it. But we'll be looking at sequence, which I think everyone's familiar with sequence, putting multiple instructions one after the other, input, output. So how does the user interact with the program? Selection, which is when you are allowing a condition in a program. So your program doesn't always do the same thing every single time you run it. It can depend on some condition, what happens next in your program. So it allows kind of a selection to happen, which is where that term comes from. Iteration, so that is what we would call loops, is what we use to perform iteration. It's just repeating instructions, and you might repeat it for a certain amount of time, you might repeat it forever, you might repeat it until some condition becomes true or false, and so on. So it's using loops within a programming language. Variables, how do we keep track of values? So essentially it's a data item. Things like your score in a game, or how much time has elapsed, or how much time you've got in a timer kind of thing. These are bits of data, they're values, and they change during the program. So we'll look at how we can incorporate variables in it, and all of these are quite easy to do in Scratch. Functions, I'll explain what that means. You don't tend to use these as much in primary, but I'll explain that in some ways we do use functions probably without realizing it when we're using Scratch. And there are also ways to create your own blocks in Scratch, but that's more advanced, which I might not get onto by the end of this session. And then other concepts we would consider are data structures. How do we, if we don't just have a single variable, could we have a list to store data in it? Again, not so much used in primary. And then the final one, which is a really important one that I think everyone has now heard of, which wasn't as popular a few years ago, is algorithms. And kids have heard this word a lot because they're always constantly hearing about the YouTube algorithms or the Facebook algorithms. It's in the news a lot. And now I suppose with AI, there'll be AI algorithms mentioned and so on. So all that is sequence of instructions executed in a specific order in order to solve some sort of problem. And whenever you write a program in Scratch, you're essentially creating an algorithm. So starting off with a sequence, the process of walking in a square is a simple one, but if you are going to actually do it, it requires a sequence of actions. So you're placing instructions one after the other to create a sequence. And in this instance, we're trying to create a square. We've put a sequence of instructions together. Therefore, we've made an algorithm for creating a square. And in this example, we would step forward, turn right 90 degrees, step forward, and so on. We do that 1, 2, 4 times for each side of the square. So sequence is a reasonably easy concept, and we're going to show you to start off how we could do that and draw a square in Scratch. So I'll be swapping between my slides and the Scratch window whilst we do this. So we're going to start off. If you've never used Scratch before, which is becoming more rare, you can find the Scratch website by just Googling Scratch, and it's scratch.mit.edu, and you'll come to this website here. And then on this page at the top, you can either click Create, or you can click Start Creating on the left here. So once you click on Create, it opens up the environment, we'd call this. It's where you can actually program something, put together code. They have lots of tutorials on Scratch, and you can see them on the actual starting page I was just on. This pop-up has tutorials built into it, so you can see how to do certain things in it. Now, I always close this down because I don't need it, but that's useful to know if you want to have a look at some tutorials. And there's also a button at the top to click on tutorials as well. If you are a Welsh language in a Welsh language school, and there used to be a button that's changed slightly here. It's now inside settings. you can change the language to Welsh, and all of this can be done in Welsh as well. So you go to language, Cymraeg, and it'll all be there. I've not seen that one before. Cool. Now, in order to do any sort of drawing in Scratch, so you have these kind of all the blocks, the instructions that are available to you on the left-hand side. They're all color-coded, so you can easily find them if you're looking for them. But you can actually add in some extra blocks. So right down the bottom on my screen here, there's a little button at the bottom that says Add Extension. So by clicking on that, you can see all the extra things that you could add into Scratch. Some of these are associated with certain bits of hardware that you can get. For example, the microbit one, which is becoming very popular. And I'd recommend if you have these microbits in your school now, you can do some very cool things in Scratch by linking microbit to it and using it as a controller for playing the games in Scratch. It's something I've been trying to do workshops for years on, but schools never had the correct software installed to do this, because you need something called Scratch Link, which allows that link to happen. And in most primary schools, it seems that the network person or whoever's in charge is actually the council. But worth looking into that if I was you, because I'm sure there'll be lots of opportunities to use that in the near future. And there's various other cool things. One of them, the Translate tool in Google. There's text to speech. If you have things like any of the Lego robots, or the older ones, I guess, or Lego We Do, you can also connect them to Scratch. But we are going to use the pen tool for this. So I'm just going to click on pen, and that's just going to add in all the blocks I need in order to use this pen extension. Okay, and you can see that now it's added the extra category at the bottom with a little pen icon and showing me all the blocks that I can use. I will zoom in on the blocks because I realize that the screen's quite big. You might not be able to see what they are easily. So first of all, we've got this pen extension. So now using these following blocks, which I will find as well, I'm not going to do it as if I was in the classroom with you because it will take too long. We're going to try and get the sprite to draw a square on the screen. And we may need multiple copies of some of these blocks. I mean, we went through how to do it in person, step forward, turn right 90. It's the same process. We're going to break that process down now and apply it in Scratch. And if I was doing an activity like this, I would actually get the kids to do it themselves first and to pretend that they were the character or the sprite in Scratch, and then apply it so that they can apply that same logic into the program they're writing. Because essentially we're just given a set of instructions just like we did in person. So in Scratch, in general, to start any game or any program, we usually use the green flag button, which is at the top here. I might try and zoom in a bit more because I have a feeling this is quite small on the screen. If I can remember how Macs work with Zoom, I think I can just press this. Yeah, cool, that'll be better. So, as I said, this green flag button is what we use to start most programs. And the way that Scratch works is it's called an event-driven language, which means that a certain event happens, and then that triggers some reaction to it. And you tell the program what to do if that event has happened. And in this case, we start the game by clicking on the green flag. That's an event. And then what we do is we use this block when the green flag is clicked to tell it what to do when that event happens, when that event is triggered. And it works just like jigsaws. We attach blocks underneath this in order, and it'll run through those instructions in order that we've put them once we click the green flag. So if I go to the other blocks that we need, which was, we're going to start with an erase all and a pen down block. Now the erase all just means if I've already drawn something on the screen before, get rid of it when I restart, rerun the program. It just means there's no ink left on the screen. So I'm going to put that in first, erase all, which is in the pen category. And then the pen down, we need that because if you imagine that our sprite, our character, the cat here, who is currently the one that we're programming for, which we can tell by this image here. Imagine the cat is holding a pen, and currently he's not pushed the pen down on the paper or onto the screen. So we need to tell him to make sure the pen is down so that it'll actually leave a trail behind wherever that cat walks around on the screen. So we need a pen down. And if at any point we didn't want the cat to draw on the screen, we could use the pen up block as the opposites. So now anything I put after this block will leave a trail when the cat moves around. So we're going to move 100 steps and turn 90 degrees. So motion, because these are blue categories, which is where all the motion ones are. I could drag a move block. It currently says 10 steps, and there's a turn block. And I guess it doesn't matter which way you turn, it'll just make a square in the different direction. And we can click inside these values to change them, because 10 will be too small, and 15 degrees isn't what a square would be. Okay, so by doing this, what's going to happen is I can see the cat has moved forward. It's drawn a line from where it moved from, and then it's turned 90 degrees. So if I was going to make a square, I would just need to repeat that 4 times. So what would be the first thing that the kids would do is just get the same blocks over and over again. And I'm going to just duplicate these for speed. So you can duplicate blocks by right-clicking on the topmost block you want to include, and that'll create another small copy of the blocks you've selected. Okay. Oops, have I not done it enough times? 1, 2, 3. Forgot how many sides there are on a square. There we go. Okay, so that's an example of where you can teach sequence. You could teach this thing quite easily off computer and then apply the same instructions on the computer. So they've thought about the same logic. Can I now apply that using instructions that were given to a computer? Now, one thing that I do notice if I draw the square here, the cat is quite big and it'll get in the way of the drawings quite a lot. So what you can do is adjust the size of the sprite quite easily. And to do that, underneath the screen, the stage we call it, on the right hand side, you can see the size of the sprite currently selected is 100. So we'll just make that a lot smaller, maybe 15. And then that'll just let us see the shape a bit better, or anything we draw on the screen. Okay, now you might be thinking that's not a very efficient way to program it, and we will get on to that later. But for now, we have created a square using blocks. And this activity could be used in maths lessons. I remember when I was in school, the most memorable maths lesson I had was we actually got to go on the computer and we did something similar to this in a programming language called Logo with Little Turtle. And actually Scratch was designed to replace that kind of thing, but then became a much more powerful tool where you can do all sorts of things in Scratch now. Okay, so we've looked at sequence. I have a sequence. I technically, by definition, have an algorithm as well, because I was trying to create a program to make a square, and I've put together a sequence of instructions that does that, that solves that specific issue. Okay, keep missing the button. So another important programming concept is input and output. So the fact that that cat on the screen is drawing a square, and I can see it visually, that is an output. The program is providing an output to me. I can see the output of the instructions that I've given it. So any information that is passed from my program to the user is a form of an output. And in the same way, if the user can somehow pass some information to a program, that could be clicking a button or typing in some sort of text when it's prompted to, that could be classed as an input. So if we were going to look at how do we do inputs in Scratch, we can do that using these blocks. So one useful one is when the sprite is clicked, we can do something after that sprite is clicked. Another thing is we can ask a question to the user and the user can then type in the answer. And it's worth noting here, when I'm mentioning user, it's the person that's using the program rather than the person who programmed the program. But in some cases, when you're obviously creating it, you're both in this situation. So useful for making buttons, and then useful for allowing the user to input any sort of text. It might be you're creating a quiz in Scratch. You could use this question and answer blocks to then check if they're correct. So I'll show you now how we can make a button in Scratch. So if we add a new sprite to the game. So let's go back here. So currently we have a cat who is our artist. They will draw things on the screen. But we're going to make, instead of using this green flag button to start the game, I'm going to show you how you could actually use a different sprite to work as a button. And that's not just useful for obviously starting a program. You could have various things, which I will hopefully, having shown you this now, at the end, I can show you some examples of how that's useful in certain examples for cross-curricular activities. So to make a sprite be a button, first we need to get a new sprite. So at the bottom of the screen here, we've got choose a sprite. So just click on that. It'll give you lots of different options when you hover over it. You can paint your own, you can pick one at random, or you can upload a sprite if you have your own image on the computer. I'm just going to choose a sprite. And there's loads to choose from. You can pick any of these. Essentially, if I click on any of whichever one I choose, I can use it as a button. There are already buttons involved, so I am going to just be boring and go with a button for its purpose of being clicked. Okay, so I'm going to click on button 1, and it adds that into my game. Now, if you're not familiar or very familiar with Scratch, all the kids will panic at this point if they are doing something like this, because they'll say, oh, my code is gone. But all that's happened is we've opened a second sprite, and therefore the instructions that we had for the cat are still inside the cat sprite. If I click on this, it's still there. It's just that it's automatically changed to show me the instructions for the button, which we haven't given yet. Okay, so I want to now use this button instead of the green flag block to start the program. So when I said that Scratch works through events, we just need a different event block, and that one is when this sprite is clicked. So in the events category on the left-hand side, we can see when the green flag clicked, when space key is pressed. So that's another event you can have if they press a key on the keyboard, or this third one, when this sprite is clicked. So if I drag this one in, and then I could just have code coming off this. I could make the button do something if I wanted to. But this subtlety is I want the button, when I press it, the cat is going to react to the button. So to do that, you need to send a message to tell the cat. The button basically says, I've been clicked, and you should do this now. So when I click the button, what I want to happen is to broadcast a message. So again, in events, there's a broadcast message 1 block. And if I click on the drop down arrow here, then it says new message. Because if you have lots of these blocks in your program, you'll start to forget what message 1, what message 2, what message 3, what they all did, what they meant. So it's nice to give them a meaningful name by clicking on new message here. And what I want to happen is, well, the cat is going to draw a square. So I'm going to name this draw square. Once I'm happy with the name, I click OK. So now I have a message. So when I click on this sprite, it's going to work like a button, and it's going to send a message which says broadcast draw square. So if I do this, you can see it lights up, so we know it's working because the blocks will light up or glow in kind of a gold color if they are activated, but nothing happens. And that's because you can send a message. Oh, let's go back. You can send a message, but that doesn't mean that anybody's listening to you. It's kind of like shouting tag, but the other person ignores you when you're playing tag. So you have to force them to listen to you. So now we need to tell the cat what to do when it hears the message, draw square. So I'm going to swap back to the cat. And all we need to do here is where we had when the green flag is clicked. That was the event that triggered the drawing of the square before. I'm going to drag off from the erase all block, drag that and disconnect it from this event block. And I'm going to delete this block by just dragging it back into the left-hand side and dropping it there. And then here, I want it to react. So it's going to run this code when it hears the message, draw square. So if you look back in events again on the left-hand side, there'll now be a block which says, when I receive, draw square. So in this case now, the green flag doesn't do anything. We have no blocks that say when the green flag is clicked. Our cat will draw a square once it hears the message, draw square. And how that message gets sent out is if we click on this button. So that is one form of doing, or how you can do it in an input in Scratch. And this input-output is an important concept within computer science, and with it, well, with how computers work. They are designed to receive an input and then output some information. Okay, and I can drag around the cat wherever I want it to go, and you can see it draws a square wherever I place it. So hopefully that's shown you how events work and how you can do an example of input and output in Scratch. The next thing would be the other kind of input we can have, which is asking a question. So if we'd like a text input from a user, we can use the ask and answer blocks. And the ask block, as you can see in the bottom here, it says ask something. You can type in whatever you want to ask and wait. So it'll wait there until the user presses enter or clicks on the tick that appears on the screen. And then I'll show you how to use the answer they've typed in for whatever you want to use it for. So in the original sprite, we're going to ask if the user would like to draw a square or not, as soon as they click the green flag. Oh, no, as soon as they have received the message draw square. So it's when we click the button, that's a typo there. You do not need to remove any current blocks. You can create multiple algorithms with the same sprite. Okay, let's quickly go there. Okay, I'm going to explain that next. So actually, no, I will make a new block for this, just in case I was actually right and I'm forgetting what I designed for this. So when the green flag is clicked, we're going to drag in here. Okay, and this is going to make the point that you can have multiple algorithms within the same sprite. So I'm still on the original, the cat here. The cat knows that if it hears this message draw square, this is what it's going to do. But it also can understand if the green flag is clicked instead, this is what I'm going to do, wherever we connect here. So what we're going to do first is I'm going to put an erase all, and that's just to save us time and debugging things later on, because we will get an issue where there'll be pen left on the screen from a previous thing unless we put this here. So first of all, in the pen, erase all is going to be my first block. And then the next thing, we're going to ask a question. And because this is a form of input, so it needs an input from the user, generally that kind of thing will be found in sensing. And you can find the ask block. So it's a light blue block in the sensing category. I'm just going to put these closer together so you can see them both. And we can type in here, would you like to draw a square? I'm going to put yes or no. It's always better to have closed questions on Scratch if you want to check what they've typed in later. Otherwise, it's very difficult. Okay. Oh, I shall leave that there for a bit. Would you like to draw a square? Yes or no. So I've got when green flag clicked. erase all, and then this ask block, which I've typed in the question I want. Okay, now the next thing. So how do we check someone's answer? And this is where selection comes into it, and probably the most common place you would use the concept of selection, which is allowing the program to make a decision based on some condition, is when you're asking a question, checking if the answer matches the answer you want. So once the user has been asked if they want to draw a square or not, we need to check their answer and make a decision on what instructions to do next. So if they say yes in this example, we can draw the square. If they say no, we just don't. Okay, and in order to perform selection in programming, we need to use an if statement or an if block. You probably call it in Scratch. Okay, and this is how it works. We've got an if block. It has like a diamond cutout where you can place an equals block in. And inside this, we can place the answer the user typed in and compare it to what the answer that we're looking for. So this area is what we call the condition. This is the condition. If it's true, then we will do whatever's inside this if block, which is at the moment broadcast draw square. If this ends up not being true, if the answer they type in isn't yes, then it'll ignore what's inside here and it'll just move on to the next thing underneath. So let's show that in the code. So in control, because we're the reason it's called control, you're kind of controlling the flow of the program. So you'll find any blocks that do that to do with selection or even repeating things inside control. And if we go here, you can see there's actually two kinds of if blocks, and I'll explain the next one later on. But for now, we're just using the normal if that looks like this, kind of like a T-Rex skull. Now I've just seen that for the first time. And in here, you can place a condition. So there's a variety of blocks that can actually go in here that you can check if it's true. You can find some in sensing, for example, if you wanted to check if it's touching something in the game, if the mouse is touching this character, if the character is touching a certain color. So there's various things you can place inside these blocks, but we're going to put an equal sign in operators. And here's this equal block, and when you're placing these blocks in, put the left-hand side of the block in the area, because if you try and put the right-hand side, it doesn't kind of clip in properly. You can see it lights up when it's happy, and it'll extend the block to fit it in. Just make sure I'm not going to run over on time today. And the next step then is we want to say what the answer should be. What do we want the answer to be? And in that case, we want to check if the person, the user of the program, typed in the word yes. And worth noting here that Scratch is what we call case insensitive. So even if I typed it all in caps or I typed it all lowercase, it doesn't matter. And it doesn't matter what the user types in, as long as it's the correct letters. So it doesn't matter if they can spell. And then sensing, because we asked a question, if we want the answer that the user typed in, that gets stored inside this answer block. So whatever they've typed in, we are checking, is it equals to the word yes? And if it is, then what do we do? So in this example, we're now going to say, so once we've done this, we are going to draw the square. Okay, so if I go back to events, when I receive draw square, nope, that's not what we want. We want to say broadcast. So just like the button, when we press that, it broadcasts draw square. Here, we're going to place a broadcast draw square block inside the if, so that when we click the green flag, it asks us, would you like to draw a square? And only if they type in yes, will it actually do it. Otherwise, it's going to ignore this and just jump on to, well, nothing else, because that's the end of the program here, the algorithm, sorry. So if we do want to check that that works, I'm going to just move the cat to somewhere else so it's not just redrawing the same square over where it was before. When the green flag is clicked, so click that, it now asks us, would you like to draw a square? And if we type in yes, then the cat draws a square. If we type in no, or literally anything else that's not yes, because we're not checking any other spelling or anything else you type in here apart from the word yes will result in the cat not drawing anything. So no means that it wasn't equals, this wasn't true, and therefore it didn't run this instruction, it didn't execute this instruction. So that's an example of selection. So if you ever see the word selection mentioned in these kind of in the curriculum or the DCF, it's essentially you only complete some or only execute an instruction, you only perform something if a certain condition is met, and if it's not, then you don't do it. Okay, so hopefully that's explained what selection actually means. And as I said earlier, it doesn't have to be just yes or no, as in one option, it does it, anything else, it doesn't do it. You could have almost a multiple choice, or if it's true, you do one thing. If it's not true, you do something different rather than doing nothing. So a simple if statement will allow a program to decide whether to execute certain instructions or not by checking a condition. If we use an if-else block, as we see in Scratch, we can choose to execute a different set of code rather than just ignoring the one in the if branch. Okay, so it says here, if the condition is true, we do this, but if the condition is false, we do something else. And you notice I changed the question here to say, would you like to draw a square or a triangle? And if the answer is square, then we draw a square. But if they don't type in square, it'll draw a triangle instead. So let's implement that in here. So the easiest way to do this, I would drag in from the events, from control, the if else block and just place it in an open space for now. And then you can start picking apart the if block we had before. So the draw square is going inside the top branch, I would call this the if branch. I'm going to drag the green block. If I click on the blue block, it'll pull that out of the green, but I want to keep that there. If I click on the green block itself, then I can drag the whole thing out and place it in here. And now I can get rid of this if block by just dragging it and placing it back on the left-hand side. And then moving this if block up, we can attach it. And it's quite a quick way of replacing that code without having to change too much. Now, what was different with the question was, would you like to draw a square or a triangle? Was the question we're asking. So I'm just going to edit this. And I'm going to change the answer. It doesn't make sense for it to be yes, unless I'm asking, would you like to draw a square or a triangle? Yes, I want to draw one of those. We should specify square. So if that's, they type in square, they do that. Otherwise, it's going to draw a triangle. Now you might be thinking, well, we haven't actually done code to draw a triangle. So that's the next step we will need to do. If I go back here. So I'm going to show you a quick way of duplicating the whole thing. I have briefly shown it, but because our code is going to be very similar to drawing a square for drawing a triangle, we're just going to duplicate the entire algorithm here. So I'm going to need more space again, but if I right click on the top block, any blocks attached then will continue to be detached if I make a copy. If I right click and duplicate, I make a whole copy of that. Now, if I have more space, I'm just going to move across and try to get these two things. Obviously, Scratch has a huge canvas. It's actually, well, almost infinite, I would say. You can drag around, but just try to make sure you don't forget which direction the other code was in and lose it off the screen. There we go. So I put these two on here. Now I don't want two algorithms that do exactly the same thing, because that will confuse the cat. It'll kind of do it both of these at the same time, which wouldn't actually affect in this instance, but would if it was a different kind of program. I'm gonna, when I receive, I'm gonna change this draw square by clicking on new message. If I click on the drop down, new message, I'm going to name it draw triangle instead. And in this case now, what we need to do is just think about how we would adapt the code that we had for the square in order for it to draw a triangle. So all of these, it's repeated 4 times. Now, if it's a triangle and it has 3 sides, we won't need to repeat these 2 blocks 4 times. We can repeat it just 3 times. So I can drag off the bottom 2 so that it moves 100 steps, turns, moves 100 steps, turns, moves 100 steps, and turns. I can delete those 2. But now I need to think about how much do I need to turn in a triangle. And you could use this in a maths lesson for probably year 5, year 6, I would imagine. It's quite a nice activity to use this for. And if you think about it, whenever you're turning and you want to end up facing the same way you started, you're doing a whole circle essentially. You're doing 360 degrees, and I'm going to be turning 3 times. So I just need to work out how many times I need to turn in order to do a whole 360 if I'm turning 3 times doing that. And the answer would be 120. So when I receive draw triangle now, it should draw a triangle. And without going through this whole thing of typing in the green flag, if you just want to check one algorithm that you have in your code, you can test that on its own by just clicking on the top block. You can see that the cat drew a triangle on the screen. Same with this one. Obviously, if I wanted to check that that one was drawing a square, you can just click the top block, and that will also activate just that algorithm. So we've got the instructions now. The cat understands how to draw a triangle. So in our, I guess, the starter code, which allows the user to choose, almost like a menu, I guess, we need to put in here broadcast triangle. So in events, we have the broadcast block, broadcast draw triangle. So we just change that one to draw triangle. And now we've got an example of selection where it actually has multiple options rather than just doing something or not doing it. It's now doing one thing or a different thing. So if I type in square, just check it still draws a square because this was true. And because this was true, it doesn't do this one. But if I go to type in triangle or literally anything other than square, it now draws a triangle. So obviously I'm putting all these things together to make it quite a session that flows together. An easier example of this kind of thing would be if you're asking a question in a quiz, if the answer is what you want, then say correct. Otherwise, say not quite or incorrect. That would be another place you would use an if-else block. Okay, so there you go. That's an example of selection being taught through Scratch. Oh, have I gone backwards there? Yeah. Okay, so this is what our shape algorithms currently look like. So what if we wanted to change the size of the shapes we are drawing? What would we need? What would need to be changed? So in this instance, well, actually, I keep forgetting you guys can talk. If anybody wants to say what would we need to change here, if I wanted to change the size of the shape algorithm of the shapes that we've got.
Come on, someone, be brave.
So it's on the screen. Here. Go on,
Oh,
Sean.
Go on. Yeah, we've got an answer in the chat. The number of steps.
I can't actually see the chat for some reason.
Yeah, I've got the chat, but yeah.
Okay.
Kathy from St. Michael's has said the number of steps.
Perfect. Yeah. So we want to change the number of steps. So if we were going to do that, at the moment, I have to change that in 1, 2, 3, 4, 5, 6, 7 different places. And that becomes a hassle. So what we could do to make this easier for us, for ourselves in future, is be a bit more clever, and we could use a variable to do this. Now, any of you that have used Scratch before and have used variables, you've probably used it to keep track of score, or to keep track of a high score. I'm trying to think what else you get. Maybe how many lives you've got, or how many points, how many questions you've answered correctly, and so on. And that's a traditional way you could use it. But there's also other uses for variables, which maybe is more advanced, but it's nice for you guys to know about kind of this way of thinking about variables as well. So first of all, what is a variable? So it's something that stores data in our program, kind of like a box, or something that it is data, or allows us to store data in the program. So if you imagine it as being a box with a label on front of it that kind of gives us an indication of what's being stored inside the box. So we can store different things in it, but the label stays the same. So for example, I've stored the word Bob in my variable, and I've named the variable name. So it makes sense that whatever's being stored in there is going to be a name. It doesn't mean I couldn't store something else in it. I could put a number in there, but that would then make it harder for me to understand my own program, because I'd be confused with the fact that I'm expecting a name to be stored in there, but somehow the number 1 was stored in there. So a variable is kind of like a box with a sensible label on it that indicates what kind of stuff we're storing. And if you've got score, for example, oh, let's just change the size, sorry, in this example. I've taught these slides in so many different ways, but they're very similar. So in this example, we've got the size of our shape. We could store a number in there instead. Now, if we decided to change the size of the shape, we only have to change what's stored in that one box, rather than having to go through a whole program where we manually wrote the same number over and over again. We have to change all 7 examples of that number. If we use a variable, we just need to change what's stored in that box, and then that automatically will apply to everything. And I'll show you what I actually mean by that if we create a variable first. So if I go to variables on the left-hand side, they already have a variable which is very poorly named, called my variable. I'm not sure how helpful that actually was when they added that in, but we're going to make a new variable by clicking on this button here in variables. And then we're going to give it a sensible name. And because this is the size of our shape, we'll just call it size. In general, when you're programming, we always write variables with lowercase letters. I know that's usually something that we're not trying to teach pupils in primary, but when they move on to do other languages, it becomes a convention that you should be using lowercase letters for the start of a variable if it's a one word. So I try to keep to that from the start. And we're going to leave it as for all sprites and click OK. And you'll notice when you create a new variable, it appears on the screen here. If you ever wanted a variable that didn't appear on the screen, in this category, you can click on the tick, which just tells you if it's showing or not. So you can control if you want to show it on the screen. Cool, so we've got our size variable now. And what that gives us then is the ability to get the value that's whatever's stored. So whatever value is currently stored in the variable size, we can use this block to use that. And I'll show you what that means in a minute. And we can set the value of size using this set block, and we can change it by a value if you wanted to add to it or take away, subtract from it, and so on. So we're going to edit our code now. So the draw square algorithm sets the size of 150, and the triangle sets the size to 50. So we're going to use the set block, and then we're going to think about where we're going to place the actual size variable block. And I would let you have more time to think about it yourselves, but we are going to run out of time otherwise if I don't just go through it myself. So my draw square, I want to set the size variable to be, I forgot what number I said, 150. So I need to use the set block. And as I said, rather unhelpfully, they've already made one called my variable, which means an extra step for me to do. So I'll drag this set block in, and I'm going to place it. You can either be above the erase all, or as long as it's above the move 100 steps, it doesn't make much difference here. So I'm just going to place it above erase all. I need to make sure I'm not changing the variable called my variable, but rather the one I just created called size. You can rename that variable, but the act of creating one is something that I usually have to teach anyway, so that's why I do it that way. And set the size to 150. And then the slide also said to set the size for the triangle, so this algorithm, to 50. So I'm going to go in here, set the size to 50. Now that's great. When I get the cat to draw a square, the first thing it'll do is it's going to set the size to 150. Or if I get it to draw a triangle, the first thing it'll do is set the size to 50. But I haven't told it where to actually use that value yet. It's still doing the default of the 100 steps I typed in beforehand and here. So this is where we can replace the number 100 with our variable size. So whatever the size is that's been defined at the top, it'll use that value. Okay, and then same with the triangle, whatever the size has been set to just before it starts moving, it's going to use this value. So now if I draw a square, the first thing that will happen is the cat will set the size variable to 150. So it's going to store the value 150 in that imaginary box that we've labeled as size. And then it's going to use the value stored in there whenever it does these blocks, move that many steps. So it makes a square, and we can see the size was 150, which is what we typed in. But if I restart, I press the green flag again to activate this algorithm we had earlier on, which lets us ask the question. If I type in triangle, the first thing it does is set the size to 50. So we can kind of adapt the size much easier now. And now in case I decide, oh, that triangle's a bit too small, instead of having to change that number multiple times in lots of different places, I just change it in one place. And if you imagine a computer program had thousands and thousands of examples where they were using a certain value and then they realized, oh, they have to change it. If they hadn't used a variable, then that's going to take a lot of time. And actually, when the VAT rates changed and so many people had programmed it to the old rates and they didn't use variables, it costs thousands of pounds for people to actually go into these programs and have to replace whatever it used to be. Was it 17.5% or 20%? I can't remember what it used to be. But that's an actual real world problem that people had because they didn't use a variable to store the value, which was shocking and something we want to avoid in future. Just some computer history for you there as well. So this is what we have at the moment then. But is our code now as efficient and succinct as it can be? Is there anything else we could do to improve our code or make it more efficient? Because we've got quite a lot of blocks here. Any ideas? I remember I can't see the chat, Sean, so if someone has typed in, I don't know what they said.
Yeah, no, sorry, nothing coming through yet.
Okay, well, I might answer it myself.
No problem.
So this is an example of where you can see if children are using pattern recognition when they're programming, because I can see a pattern here I'm moving a certain amount of steps and I'm turning a certain amount of degrees. And then I'm moving a certain amount of steps, turn degrees, and again and again. So there's repeating instructions here. So by recognizing that pattern, I can then apply my understanding of programming, I guess, to shorten the code and make the code more efficient by using a repeat block instead. Instead of having to type out or place all these blocks over and over again, we only need one copy and just say, why don't we repeat these 2 blocks 4 times? And in this example, why don't we repeat these blocks 3 times? So that's where it comes on to iteration. So being able to recognize patterns and instructions, that's an important skill. And in programming, we often need to repeat a set of instructions multiple times. So it makes code more compact and manageable. And we're able to use loops to do this rather than repeatedly writing or adding blocks over and over again. And again, it's the same issue with that variable we had before. It's easier to fix mistakes if there's only one copy of the code rather than if you've got multiple copies of it. Okay. So we're going to adapt our code again now using a repeat certain amount of times block. So in Scratch, there are kind of 3 different types. There's a forever block, which will just repeat or iterate forever. One that we can decide how many times exactly it repeats. And there's another one where you can say repeat until some condition becomes true. So if I use this simple repeat block, we can then shorten our code. Ooh, press the wrong thing there. Oh, I showed the answer. We can now shorten our code and recognize we only need the first 2 blocks of these blue ones here. I can delete the rest. And the same thing here with the triangle. If I go to repeat, and again, I can drag it on. When you're placing it, you can kind of hold it over the place and it'll kind of give you a preview of where it's going to go. So you can see if you put it in the right place or not. And it'll kind of swallow the blocks you want. So place it above the move size steps. And then all I have to do is say how many times I want these 2 blocks to repeat, which is for a square, 4, and for a triangle, 3. Okay. And just to prove that does work, I've got my big square of 150 and triangle of 50, and it still works the same way. So by applying a pattern recognition there, we can shorten our code, make it more efficient, and so on. Now, the last part we'll have to rush through, I think. So if we look at both these algorithms, can we see a similarity between them? They are identical in what they do. They both react to some message. They set the size, they erase all, pen down, then they repeat these 2 instructions a certain amount of times. The only thing that's different is the actual values in here. Okay, they both draw shapes. Again, by recognizing that brings us on to how we could make a function. And this is the last thing that I would mention here. The last kind of term that I will actually go through. And it's something we don't really mention much in our primary workshops, but it's worth knowing what it is so that you're aware of the idea of a function, because you do technically make these probably in some of the programs that you would make with pupils. So in a way, what we have done so far is to find functions for drawing a square and another for a triangle. So in Scratch, the act of using when I receive and broadcast, it's kind of like defining a function and calling a function. And all a function is basically an algorithm which has a name. But if it is also possible, but it's also possible to define our own blocks in the MyBlocks category. I'm not going to go into that today, but you can use MyBlocks to create a function which is literally defining it and drawing. You can make your own block basically rather than using the broadcast way. It does the same thing essentially. So I just want to show you how we could make these 2 separate algorithms which looked completely different at the start, but actually by using pattern recognition, breaking it down, decomposition, we can see that we can actually just have one function that does any shape with any amount of sides if we use a tiny bit of maths. I promise it's a tiny bit. So we're going to delete the triangle algorithm. I'll do that. We're going to rename the draw square to draw shape. Okay, so if I go in here, when I receive draw square, I'm going to rename it draw shape so it makes more sense. But remember, I also need to do that here. And we need to create a new variable called sides. And apologies, I'm rushing through this, but hopefully with the recording, if you needed to catch up on this part, then you can do so. Set variable to make a variable called sides. And then once I've done that, I'm going to place the sides value block where they should be used. Now, in a classroom, I would get people to think about this. And when I say classroom, in a CPD session with teachers in person, I mean by that. So the sides block, if I wanted to make any shape, the degrees is what's going to change, as well as how many times I repeat these instructions. For a square, it's 4, and I turn 90 degrees. For a triangle, it was 3, and I turn 120 degrees. And those numbers both are related, and they're related to the number 360, which I kind of alluded to earlier on. So if I know the number of sides of the shape that I want, okay, so if I know that the sides is going to be 360 divided by the number of sides, that will give me the angle that I need to turn. For a square, 360 divided by 4, this sum gives me 90. For a triangle, 360 divided by 3, this sum will give me 120. So I can turn that calculation degrees. And here is just the number of sides. Now this is more complex than I would do with school children, but hopefully you can see how this applies. And when I'm teaching this, obviously I want our teachers to be slightly ahead of the pupils that they are teaching and what they're teaching to their pupils. Okay, so in the main code then, with the green flag, we're going to replace the broadcast blocks with a block that sets a number of sides for each shape. So I'm going to edit this because we don't need to make a choice between a shape, a square or a triangle anymore. We just need to, whatever they type in for the question, how many sides should your shape have, or something along those lines. So they're going to type in a number. We can set that number, the sides variable, to whatever they type in. And then we can broadcast draw shape. So we're not using any selection here. It's all based on what the user types in. Okay, so let's see if this works. We're going to type in how many sides you should have, set the sides to the answer, broadcast draw shape. Once that message has been sent, set the size to 150. Make sure there's nothing on the screen, make sure the pen's down, and then create the shape using the number of sides that were typed in, the size that we've set, and this will calculate the number it should turn each time. So how many sides should your shape have? We can type in 3, it'll draw a triangle. We can type in 4, it'll draw a square. And now you have a bit of code that could draw a shape of any number of sides, a regular polygon. So let's go 6, and so on. So now I've got a slightly different function to the two I had before. One was a function for drawing square, one was a function for drawing a shape, drawing a triangle. But then I've realized they're essentially the same thing. If we use one little calculation, we can have one function that draws a shape. But again, just to make the point, functions are just an algorithm which you have a specific name, and I could use that name over and over again. I could just broadcast draw shape whenever I wanted to, and it would draw a shape in my program. So that was a whistle-stop tour of how you can teach these concepts in Scratch. And there are, if you were putting together just a single activity that taught each of those, you could get easier examples of them. It's just I was making one narrative throughout to show how they can all link together as well. So some of the pedagogy I applied, if you aren't familiar with kind of programming pedagogy, the one that we use a lot at Technocamps is called Parsons problems. Essentially, it's you give learners all the blocks that they need to achieve what they're trying to do, but you don't give them in the order. You kind of get them jumbled up, and then ask them to put them together to try and achieve what you're trying to achieve, which lets them think through the process, and they can use trial and error. If it doesn't work, they can think about, okay, why isn't that not working, and then try and debug the problem and fix it and get it to work. One that I would normally do in a classroom but don't have time to fit in today is prim, which means you can give them code, ask them what they think it'll do, so they predict what they think it'll do. They can run the code. Turns out the code actually doesn't work or doesn't do what they think it will do, so they investigate why. They can then, after debugging the problem, modify it to see if that's fixed the problem, and then ask them to make a similar program. So that's another good pedagogy to employ and look into if you are looking to teach these sort of things. And computational thinking, we've used that throughout. So the four main concepts of those: decomposition, abstraction, pattern recognition, algorithms. So hopefully by going into depth on these, you can see what these terms are, what they mean, and how you can apply them in a programming language like Scratch. There are resources that I put together in this link, which basically is the slides for this session. And there might be a code, I can't remember, I put this together such a long time ago, but you'll have all the slides there. And then this extra link is resources that I've made, tutorials as well, for how you can use Scratch to teach 3 different cross-curricular activities, one being states of matter, so solid, liquid, gas, how do they behave, and you can program little dots to move around. Another one is a translation game, so making a quiz that automatically uses Google Translation to test out their what's the word in English? Vocabulary in English or in another language, sorry. And then the third one being a animation of a water cycle, which can be used in geography or science lessons. Oh, I've actually got them on the next slide as well, so you can see an example of the kind of things you can make. And there's another link to them, to the YouTube playlist, and it goes through it all step by step, and available in Welsh and English as well. Other ideas of where you could use Scratch across the curriculum. So when I was showing you how to use buttons in the start, another way you could do that is having, for example, an interactive kind of file of facts, I would call it. So if they were doing work on, I don't know, the body or different countries in the world, you could have buttons, which when you click on them, just says information. So it's a nice way of presenting information they've learned in another lesson and so on. And various other ideas, which I'll skip through quickly. But and then I guess teachers don't really have time to do this sort of thing, but it can be used as a teaching tool for making something that can highlight something. I create lots of teaching tools to explain concepts that are difficult for students to grasp, maybe. For secondary schools, I've made a little interactive thing for explaining searching algorithms, which has doors for binary and the other one, I can't remember the name of it right now. Linear, binary linear searching. There's a workshop I've made in Scratch that use kind of cryptography stuff, so that you can look into that activity, and you'll have these slides, so you can check out all these links as well. And last thing, for those secondary teachers who are in this call, yes, I think it's relevant for secondary, because you can do all these cross-curricular things in Scratch, as well as teaching the programming concepts. Lots of schools will say they want to move on to written programming languages in year 7, 8, and 9. But I think for year 7, you could still teach Scratch. And that brings me on to the next thing I wanted to quickly show, which is a tool that we're currently working on with the University of Dublin, which is they're designing it as a transition tool from Scratch to Python. So it's built to emulate Scratch, and it looks exactly like Scratch in the game side. And then they've created a way of translating Scratch code into Python code. So it gives them a nice introduction to Python in a familiar environment. And we're actually running a first CPD session on this to kind of get some feedback from teachers of what they think and what kind of features would make it more helpful tomorrow at 4 p.m. through Teams. So if anyone is interested, join us. We're looking for more feedback, and hopefully this will be something that'll be available for everyone. There's lots of tutorials on the website, which I'll show you here. So they've already got some stuff on the Pitch website at the moment, but still being worked on. But something to look into if you are interested in that. Okay, I think that has brought me to the end.
Well, Luke, what can I say? Huge thank you for what you've shared with us this afternoon. I know there's a lot of information in there, a lot of different concepts that we need to be aware of and how they can be taught and kind of demonstrated through that kind of one idea through sort of drawing shapes and so on. Whilst that might seem quite basic, I think in some cases we need to start at that level and develop our understanding of Scratch programming. Excuse me. Again, starting at that level, just so children understand how to use it properly. We don't just dive straight into trying to create games without that real understanding underneath of actually what do all these things do and why those skills are important. So can I just say a massive thank you to you for sharing that information this afternoon. And I appreciate, for those of you who stuck with us all the way through, there was a lot to kind of process there. And I think Lucas, you kind of mentioned it halfway through that with the video recording being available, it might be useful to go back, kind of have a go at practicing some of these skills, pause it where you need to. But there's a huge amount of resource available on the Technocamps website to support you with this as well. I've popped all the links in the chat to the sessions that Luke was sharing then around Scratch and the progression across the curriculum. But if you need any further support, please do get in contact. And yeah, just a huge thank you again, Luke, for your support this afternoon.
No problem, it was fun.
Okay, guys, well, that does bring us to the end of today's session. Again, a huge thank you to all of you for joining. I know lots of you now have to leave for your staff meeting. Once I've managed to download the video and edit it, it will all be available via the network and also via the Support Our Schools website. So again, a huge thank you to everyone. Thank you to Luke and to Simon for his video presentation. I look forward to catching up with you again very, very soon. Diolch yn fawr, croeso, and we'll see you again.